one of the popular libraries for Node.js is known as Express. Express is a framework for building web applications in Node.js. And if you want to use Express with Node.js and GraphQL, you're going to need to install another library, which is known as express-graphql. So let's do exactly that. Back in the terminal, what I'll do is I'll first clear out all of the outputs. So what I'm going to do is yarn add, first of all, Express, the framework, as well as express-graphql, like that. Now, back in the editor, what I'm going to do next is we're actually going to have our Express dependency. We're going to require it like that, Express. And with that in place, let's actually initialize our application. So we'll have an app. We're going to call Express like that. And then finally, we could just simply do listen. Let's say we're going to have a port of 3000, and then we're going to pass a callback. We're going to say console log. Let's say listening on 3000. And the rest over here, I'm actually going to just comment it out for now. Let's go back up, and then in the terminal, I'll go back, I'm going to clear this out. Let's do node. That's going to start this service on port 3000 if I open a new terminal. So what I'll do is, actually, let's do curl localhost 3000, and we get a response, some HTML over here, but this basically says that we cannot get the /route because we don't have any route definitions in the application, but that's fine. Right, so in order to hook up GraphQL to Express, we're going to need to have another import. So let's say we have an import for GraphQL HTTP. This would be the main middleware that we're going to have to use. So this is going to come from GraphQL Express. And then we're also going to have our build schema as well, because we need to build a schema for GraphQL. So this is going to come from GraphQL JS library. So then once we have the application, let's also have a definition for schema, just like before. In fact, what I'm going to do is I'm going to scroll down. I'm going to grab all of this stuff from here, actually including the fake database that we used to have. So I'm going to paste it back in. I'm going to uncomment it. So we're going to use the same stuff just like before. So we're going to have a database with the users. We're also going to have a schema. We have a root value. Now, in order to hook up GraphQL to the app, we're actually going to have to use the middleware. So what we do here is define an endpoint. It's going to be GraphQL. And then we pass in the GraphQL HTTP middleware, and then we also have to pass an object with the configuration. So we have to pass the schema, we have to pass the root value, and then finally, remember the graphical IDE that I mentioned in the beginning? Well, we could actually set it up over here as well. So we could say the GraphQL, or graphical actually, we could set it to true. So what this means is that the graphical interface is actually going to be available from the browser. So back in the terminal, I'll go back to my first one, the first tab. I'll actually stop it and run it again. So now we're actually listening on port 3000. So in this case, I'm going to go back to the browser. I'll type out localhost 3000 like that. And we're going to have to go to the GraphQL endpoint, which is going to load the graphical interface. And what we can do here is we can actually start executing queries. So for example, we have the users query in our main query type. We can request the ID as well as the email, and let's say the avatar URL of the users. In order to run it, you could just simply do Control Enter. And it seems like we forgot to add the avatar URL in the database. So I'll scroll back up. What we can do here is I'm going to actually add it for both of the objects. Let's do avatar URL, and this could be just a simple URL. For now, I'm just going to say HTTPS. Let's do gravatar.com. And then something, right? So, and then we're going to have to also restart the service. And now this is getting actually annoying. So what I'm going to do is I'm going to do yarn add. We're going to add a dev dependency of supervisor. So supervisor is kind of like NodeMon or Forever, which is a library for basically running your Node.js server locally and also listening for file changes as well. So what I'll do is once we have the supervisor, in fact, we can just basically go to package JSON just to verify. Now we have a dev dependency of supervisor. So what we could do back in the terminal, so I'll do npx supervisor. I'm going to run this basically on the index.js file with the dot. So now back in here, I could actually run my query now. And there we go. We got two objects with the avatar URL as well as the email and the ID. And then I'm going to also prettify this. So get rid of the other stuff like that. And we get the same result. So just to reiterate, the response is basically a JSON object that is always going to have the data field. So this is something that you saw before in the terminal. Always when you get a JSON response from your GraphQL endpoint, it's going to be prefixed by the data property. And then the data property itself contains the object with all of your fields that you requested. So in this case, we have the only one, which is users, and that corresponds exactly to the user's query. And then finally, we get the array of user objects. Each object has an ID, has an email, as well as the avatar URL. Okay, so I'm going to delete the rest of the code over here because we don't actually need this. And then there's quite a few interesting things that we can actually explore over here. So apart from the main query type, there's also another built-in type, which is known as mutation. So what mutation allows you to do is to create actions on your GraphQL server. So for example, one of the typical actions in a CRUD application would be to create a resource. So in this case, we could have a function, let's call it add user, or actually a mutation function. So what this is going to do is it's actually going to accept an email, which has to be a string, and it cannot be null. So we're basically saying that this email address is a required field. We could also ask for a name, which could be optional. So in this case, I'll just say a string, but I won't add the exclamation because in this case, it will be optional. And then when you call that add user action, we're going to expect to get back a user object, or basically an object of the user type. In order to actually implement this add user function, we're going to have to add it in the resolvers object, on this rootValue object. So what I'm going to do is, let's say we have an add user function, and what we're going to do inside of the function is, let's say we're going to create a user, which would be an object. We're going to set the ID to date now. In fact, the other thing we could also do is, let's say we could also import the crypto library, which is not actually a library, but it's actually a built-in module in Node.js. And then once we have crypto, what we could do here is, let's say crypto.random bytes. We could have 10 bytes, and then we can just basically call this to string, and this would be more or less unique identifier. And then we can have our name as well as the email address. So let's have name and email. Well, you might ask, where do those properties actually come from? Well, they're going to come from the arguments object, which is one of the arguments that this function can expect. So once again, these curly braces define a function. The function is known as add user, and this function is going to expect arguments. Now, one of the arguments is known as the arguments object, which basically refers to the arguments that are going to be passed with the query to your GraphQL endpoint. Now in this case, the arguments, we could actually destructure them, and we can grab the email as well as the name, right? And once we have the user object, what we could do is we could do users collection on the database, push that user object, and then finally, we're also going to return that user object like that. So back in our browser, if I just refresh this page, what we could do here, instead of the query, we can now have a mutation. Now, in order to distinguish between queries and mutations, for the mutation, you could simply add the mutation keyword. And then we could say add user. Let's say the user is going to have an email, and this email could just simply be, let's say, alex@gmail.com, like that. And then finally, we're going to expect an ID. Let's also have an email address, and then let's see the name. I'm expecting it to be null. Let's run this. It looks like I forgot the hex argument to the toString method, but if we save that, let's rerun this, and this is the object that we're going to get in return. So it has an ID, also has the email address, and then the name is null because we basically did not specify it. If you don't provide a name, this is going to be undefined, which is why we get null. So that's basically a rundown of mutations. Now, apart from that, we could also have queries that accept arguments. So for example, we might have another query. Let's say it's a user. In this case, it's going to accept an ID, which would be required. And again, it's a type of ID, which is a built-in type in GraphQL. And then finally, this is going to return a user. And of course, like always, we're going to have to write a definition for that user. So what I'll do is I'll add another entry over here. It's going to be a function that accepts args. And then in here, what we could do is we can go into users, and then we can find a user such that that user ID matches the argument's ID. Like that, and then we're going to need to have a comma at the end like that. So if I go back to the browser, if you refresh, we can now write out the query for our users. So let's say we're looking for a user such that it has an ID, let's say of 1, and then we're going to have to ask for an email, and maybe let's also ask for a name. So if I run it, we get alex@gmail.com. the name is Alex, and that refers to this first user over here. And this is basically how you would pass arguments to your queries. Now, of course, using GraphiQL, there's actually a bit of a different approach to this. So with queries, you could also specify a query keyword. So this basically tells GraphQL that this is a query. It's the same thing as not passing the query parameter, but it's kind of useful if you want to distinguish between mutations as well as the queries. But if you want to pass in arguments, you actually have to specify the query, and then you also have to give that query a name. So let's call it get user. That query is actually going to expect an ID of the user. That ID variable is going to be of type ID, right? And then in user, instead of hard coding the value of 1, this is actually going to be a variable. It's going to reference the ID. I'm going to pass it like that. And then finally, in order to actually have a definition for those variables, you can expand the query variables section over here at the bottom, and then you provide a JSON object with the variables. So in this case, we're going to need to have an ID, and it could just simply be 1. So if I do that, let's do Control Enter, we get the same object. If I change the value to 2, let's rerun this, and we get max. This ID is basically being passed to the query as a variable, and then it's also being passed to the actual query on the user, like that. And once again, we're expecting the email and the name fields. So as you can see, this is more or less fairly simple for individual types. So in this example, we're basically not going any more levels deep than 1. So essentially, we're just having users in the main query type. But what if users had messages? So what I'll do here is I'll create a new collection of messages. This is going to be an array of objects. Each object is obviously going to have an ID, like that. And then we might also have a user ID. So let's say the first message corresponds to user 1. Let's say a message also has a body. So we might say, for example, something like hello, that was the first message, and perhaps also a timestamp like that. Or actually, let's call it created at. And this could be just simply date of now, which is going to be an integer value. And I'm going to do the same thing for the other users. So I'll just copy it over. And then for this one, let's say this message is going to be ID of 2, user 2, the body is going to be hi, something like that, and I'll copy it over again. And the last one, I'll do ID of 3, user ID is going to be 1, and then we can have a body of, let's say, what's up, something like that. So we can save it now. So in order to actually add those messages, I'll add a new query. So this is going to be messages. This is going to return an array of message type, which we're going to have to create. Once again, the array itself cannot be null, but also the object inside the message cannot be null either. So that's why I have the 2 exclamation points. And then we're going to have to create a new type as well for that message. So we're going to add a new message type, has an ID, which has to be an ID, GraphQL ID. It also has to have a body, which needs to be a string, cannot be empty, cannot be null. And we're going to have a created at field, which is simply a string like that. Now, the reason that this is actually a string, because, well, the date of now is actually going to be an integer, but it's fairly long. It's actually more than what the integer value could possibly represent, so it has to be a string. And then finally over here, we're going to have a messages function. This is going to return database.messages like that. I'm going to put in a comma. So I'll save that. So now I'm back in the browser, so I can refresh that. And then if I delete everything, we can now query messages. And we can ask for ID, we can ask for body, like that. We get all of the messages, but it will also be useful if we get messages by user. Now, this is where we actually need to work with the nested types. So the thing is that users have messages, meaning that the relationship is such that a message belongs to a user. So how do you represent that? Because let's say we ask for users and we also want to include messages. So let's go back to the browser. What I mean by that is, let's say we create a query for users, right? And let's say I want to know the email address of the user, but I also want to know the messages for that user. And for every message, let's say I want to know the body of that message. Now, this would not actually work. If I try to run that, we get an error, cannot query field messages on type user. Now, that's because the users don't actually have messages yet, but we could simply add them. So what I'll do is, let's say users will have messages like that. We can have a message type. This would be an array. If I save it, we have supervisor running. So if I just refresh the page, again, we run it, but we get cannot return null for non-nullable field user messages. So what's happening behind the scenes is that we're trying to access the messages property of the user object, so let's say the first one, but there's no messages property on the user. So like, what do we do in this example? Well, with GraphQL JS or even express-GraphqL, there's not really that much you could do. One of the typical ways you would handle this is you would create a model class for user. So we might have a class for user. So let's say we have a constructor. The constructor expects a user object, right? And then what we can do here is we could, inside the constructor, call the object assign method. So we could assign all of the properties of the user on the current object, which would be the object of type user, right? And then finally, here we could create a new method. We can call it messages. And then finally, what we could do for the messages is we could do, let's have database messages. We're going to access the messages collection. We're going to filter it down to those messages whose user ID matches this ID, which would be the ID of this user, the user object that we pass in. So now if I actually scroll down, and when we return the users, we could actually map them. So I'll do a function, call back the closure function. We have a user, and I'll wrap each user in the user class, and I'll pass in the user inside. So going back to the browser, if I now run this, we actually get the messages over there nested inside. So how does this actually work? So when we have the users type, we access the users collection, essentially just a property of the fake database object that we created. So we're accessing this array. And then when we map through that array, we actually wrap every user with the user class. Now every user class will have a messages property, essentially a method actually. It's a method which, when you invoke that method, you're going to get back all of the messages that belong to that user. And we filter down those messages by the user ID. So of course that's one thing you could do, and besides that you could also make this method a getter. So you don't necessarily have to have it as a function, but this could also be a getter function which you invoke as a property. So if I save the file and if I run the query, we're gonna get the exact same result back. Now if you're kind of curious how this actually works, if I open up the network tab in my browser, I'm gonna magnify it once again. So once I actually execute the query, and in this case we don't actually use any variables, we don't need them, so I'll close that off. What actually happens is if I run this query once again, you could see a request coming out to the GraphQL endpoint, and what we get here is a post request. So what's happening is it's actually executing a post on the GraphQL endpoint on our server on localhost 3000. What it's doing is it's actually sending out the query as the value in the payload, and then as a response it's getting all of the data. So what we could do here is we could actually mock that request in order to see the mechanics of GraphQL. So we can just simply issue a request. This will be a post. I'm going to set the header to content type application JSON, like that. And the data needs to be an object, so I'll use single quotes. I'll pass in a JavaScript object. This has to be JSON stringified. So we're going to have a query field or a key, and then as the value we're going to pass in another object. Inside of that object, this is basically going to be the query itself. So what I'll pass in is, let's say, users, and for every user we're going to expect an ID. And finally I have to specify localhost 3000, and I'm also going to add a new line at the end like that. If I run it, I get cannot post to slash. That's because I forgot GraphQL. But if I add that, there we go, we get the data back. So we get back the users array, which contains all of the user objects with the ID. And of course we can modify the query to add more fields. For example, apart from ID, we can also ask for email, we could ask for avatar URL, all of the other stuff as well. So it's going to work the exact same way. So as you can see here, all that GraphiQL is doing is it's basically making a post request with some JSON, so content type application JSON, and it's passing in some value, which is typically an object with a query. Sometimes you might also have variables if, let's say, we're querying an individual user. And then as the query itself, you pass in the query that you would typically type out in GraphiQL. So that's how GraphiQL works. It takes in the query, it passes in the query as a payload, and then sometimes it also includes, like I said, variables. As you can see here in this example, it's actually null, but sometimes it's an object with the actual values. And then as a response, you get back the JSON object from the server. But like I said, this request is actually the meat of GraphQL. So it's something that you might imagine creating from a client. So you could actually make an AJAX request. And this is basically how some of the clients for GraphQL actually works. So something like Apollo client is actually making AJAX requests to your GraphQL server, just like we could simply do from the terminal. So once again, I want to emphasize that GraphQL is not a storage engine or a database engine. It's just simply an abstraction layer on top of the existing API. And it comes with a query language that basically allows you to create queries for your GraphQL service. When you query your service, your GraphQL service, you basically issue queries with the specific types of data that you want to access, as well as the specific fields of those types that you want to get back. In this case, we're interested in users, but let's say users might have a bunch of different fields, but we might only be interested in, let's say, email, as well as the messages body. So we specify that type of data and we get back that exact data in that exact format. And of course, if your GraphQL sits directly on your server, so you have a direct interface with the database, you might also have a selection of specific fields from that database. So you might imagine that the web application could be very efficient, even on slow connections, when we have to be careful with the amount of payload that we're exchanging between the servers. So that's basically it for the introduction, guys. And once again, like I said, this approach with the classes is kind of tricky because once you actually start going into multiple levels of types, if you have nested types, it gets more complicated. And of course, there's different tools to manage that. One of the tools is known as Apollo server, and we're actually going to look at that in the very next video in detail. So thanks for watching, and I'll see you then.